Hello and good morning. Let's take a look. Make sure you bring your computer and charger the day you test for the PSAT. If you don't have a computer, make sure you get to the media center and check one out. Okay, what's the difference between Hamilton and Jefferson? Well, let's think about this. We're going to use this problem and we'll show you. Okay, so we're going to add up these numbers. So get your calculator out. So we're going to clear it. We're going to take 40 plus 35 plus 25, press equals. So the total here is 100. Okay, we're going to divide by 15. And we get 6 2/3. So we get 6.6 repeating. That's your standard divisor. Okay, what you're going to do now is line these up, and you're going to take 25, 35, and 40 and divide by the standard divisor, which is 6.6 repeating. Okay, so let's do that. So we're going to just use 6.6. So 25 divided by 6.6. And we're going to change that to a decimal because I can't read that one. I get 3.787. So 3.787. 35 divided by 6.6. I get 5.30. Okay, and then finally 40 divided by 6.6. I get 6.06. So the quota, which this should be right here, is the whole part. And Hamilton said regardless of the decimal, you write down the numbers. So that's 3, 5, and 6. If you add that up, you get 11 plus one more, you get 14, not 15. So Hamilton said you had to look at your decimal, which is this one. So you want to make this one a 4, and thereby giving you 15 representatives. And there it is. And that's Hamilton's plan. Now, on Jefferson, you would take the 25, the 35, and the 40, and you would divide not by 6.6, but you would divide by something like 5.0 or 5 and see what you get. Okay? Let's see what you get. So 25 divided by 5 is 5. This is 7, and this is 8. And if I add that up, that's 8 and 7. That's going to give you 15. Already it's too many. So that's going to be 20. And we want 15. So you'd have to go up to 6 and see what you get until you get 15 representatives. And that's the difference between those two plans, okay? Now what I want you to do, open up a book to page 177, and I want to go over these two that you're going to need for today. So on page 177, right here, okay, so page 177. Let's see here. Right there. Okay, this is what I want. Page 177. Okay, so the absolute unfairness is the average consistency minus the average consistency of the other one. Okay, now what you do there is this. You're going to add 1 to either one of these. Okay, so you're going to take this one right here, you're dividing by 10, okay? So what you're going to do is add 1 to that and divide by 11. And so you're going to get a new number here. You're going to do the same thing with the other state. Instead of 5, you're going to divide by 6 because you're going to add 1 representative there and you get this. And what you're going to do is subtract these two. So you're going to take the old one for this one minus that one. Okay? So write that down. 1600 minus 1390. And then on this other one, you're going to go diagonally and you're going to subtract these two. So it's going to be 1688 minus 1455. And when you do that, you're going to get the absolute unfairness, which in one of these will be 213, okay, the 168 minus the 145, or 1668, that's going to give you 213. And the other one is going to give you 210. Okay, and I'm just looking right on the book right here. And there it is. Okay? So that is the absolute unfairness of the apportionment right there. Okay? And then down here, the relative, the formula is right here. So if they say find the relative, you're going to use the absolute unfairness of apportionment divided by the average consistency of the new representative. So write that formula down. Okay, so today you're going to be working on 1 through 7. I want you to do this first, even though I have it written second. And then I want you to do the worksheet second. Book first, worksheet second. Make sure you check your answers. Okay, let's turn our attention now to college algebra. Okay? All right, so to work these, let's see what we're doing here. So this one, I want you to extract the perfect root. So this is really 2 times 4. So you could rewrite this as 2 times 4. And the square root of 4 is 2. And 3 times 2, you multiply and get 6, square root of 2. Make sure you know how to extract perfect roots. This one, you just need to get rid of this. So you're going to multiply by the square root of 3, top and bottom. So you're going to get 12, square root of 3. 3 times 3 is 9, and the square root of 9 is 3. So 3 times that 5 is going to give you 15. And then you can reduce both of these because they're on the outside. So 3 goes into this 4 times, 3 goes into this 5 times, and now you're done. All right, let's talk about page 116. Copy that down. Open up a book to page 116. We're going to do FOIL. So it's going to be 2 times 4 is 8. When you multiply this, you're going to get plus 6i. Now what you need to know is the square root of a negative 1 is equal to I. And then if you square both sides, you get I squared is equal to negative 1, because this cancels. Okay, so there's 2 things you need to know. The square root of a negative 8, there's your negative 1 right there, right? Negative 1 times 8. The square root of a negative 1 is I. So the answer here would be I times the square root of 8. And they like the I in the front. Let me see if I can get this focused a little better. Okay, so now we're going to keep going. So we're going to take this times this as a negative 4i, and then this times this is going to be a negative 3i squared. Okay, so these two combine to give you 8 plus 2i, and then this one right here, the I squared, is equal to a negative 1. So this is really a negative 1, and so that's going to give you a positive 3. You're going to add that up and get 11 plus 2i, and that's how you do that. Make sure you understand. This one right here, you're going to write it twice. 3 plus 2i, and then 3 plus 2i. Write it twice. So go ahead and work that one. Well, 3 times 3 is 9. 3 times that is going to be plus 6i. 2 times that is going to be plus 6i. And then this one times this one is going to be plus 4i squared. And I squared is a negative 1. So you're going to get 9 plus 12i minus 4. 9 minus 4 is 5, plus 12i, and you're done. Okay? This one you're going to multiply by the conjugate, because you can't have I down here in denominator. So you're going to write the, not the opposite, but the conjugate. So you're going to change that minus to a plus, just like this. And once you do that, you have to do FOIL. And when you do FOIL, you're going to end up with I squared, and you're going to get rid of your I. The outer and the inner are going to cancel. Okay? All right, try this one. Multiply by the conjugate, and then I'll work it for you. Okay, let me try it. So I'm going to multiply by 2 plus I. So here I go. So the bottom is going to be 2 times 2 is 4. The outer and the inner cancel. So I'm just going to do negative I times I is a negative I squared. I squared is a negative 1, right? So that's going to be 4. That's a double negative here. That's going to be plus. So it's going to be 4 plus 1, which is 5. So on the bottom, you're going to get 5. And on the top, you got to do FOIL. And whatever you get at the top is okay. All right, your work is right here. If you get stuck, ask questions. Make sure you check answers. Also, bring your calculator, your computer the day you test. So computer and charger the day you test. Make sure you bring that charger. All right, have a good morning.